Hello, welcome to Computer Architecture. In this mini lecture, we are going to talk about three things. What is instruction? What is instruction set? And what is MIPS? And what is the store program concept? First, what is instruction? And the big question is that now we have a computer, but we want it to complete some task. Then how do we communicate with it? We need to have some kind of computer language, and that's the purpose of instruction. And in terms of language, there's the notion of word, there's the notion of vocabulary. In short, we need to have certain kind of computer's language so that human can communicate with a computer. And in terms of computer language, the word means each instruction. And the set of the instructions is similar to the vocabulary in computer's language, which is called instruction set. Then we know human language and there's computer language. What is the major difference? In terms of the computer language, the instruction set that we want to cover is that it's deterministic and there's no ambiguity because in a sense, computer, the way we build it is pretty dumb. If you made it ambiguous, some instruction may have two different meanings, then the computer kind of gets stuck. It will not run as expected, okay? And one major difference is that in terms of human language, there are huge variety. But in terms of instruction set, they are actually quite similar. And that's because many of two reasons. The underlying hardware technology in terms of how you build a chip, in terms of architecture design, they actually share similar principles that we are going to cover in the future. And one key principle is that we want to make the hardware, make the equipment simple. And that's why when we design the instruction set, when we implement, realize the instruction set, actually they are quite similar. And the type of instruction set that we are going to focus on in this course is called MIPS. The reason that we want to focus on MIPS is that if you follow the literature, follow the industry, you will know that the ARM processor are actually quite popular nowadays. And then the version 7, version 8 are very similar to MIPS. And then in the major difference between V7 and V8 is that V8 is a 64 bits. Okay, later on we will know what the bits means. Okay, and then x86 from Intel is actually also very similar to MIPS. Of course, it's more complicated, but we start simple. And then if you understand the principle of MIPS, the design of MIPS, actually you can easily learn all this ARM and Intel instruction set. And the type of MIPS or the types of instruction set, there are kind of two different categories. The first one is called reduced instruction set computer, which in short is RISC. And then MIPS is type of RISC instruction set. And it's different from complex instruction set computer like CISC6. And then the difference is that for RISC, it's in each instruction, it supports only a single low-level operations that kind of map to how the hardware is executed. And on the different side, complex instruction set computer, a single instruction may need to execute a series, multiple step, multiple operation. Okay? And then here you should ask yourself two big questions. Why do we have different design? And then what are the trade-offs? Okay. And then in terms of RISC-V, the other category is RISC-V. And then that's also very popular. And then you should think about and do some research about like what's the major difference between MIPS and RISC-V. Even though they are similar, they share similar principle. You understand one is not too hard to understand the other, but like at this point, it's good to understand the difference. And the particular type of concept the computers that we are going to study, we are even going to build, is called stored program concept. Remember, right? We have instruction. That's how human communicate with computer, so the computer can solve the task that we want it to compute. Okay. Then there needs to be a way to store all those instructions. Then in this particular concept, the instructions are stored inside the memory and then sequentially. And then the key thing is that the instruction and the data actually are stored at the same places. So if you look at the illustration on the right button right here, the memory unit store both the instruction and the data and the instruction are stored sequentially. So why is sequential important is that the instruction, they just execute one by one. Unless you encounter a conditional instruction or the jump instruction, say that, hey, you need to bypass a certain instruction, go to the other place, then you need to execute something else that we will see later. And then in terms of this computer, right, the key thing is that you need to fetch your instruction from the memory unit, and then you need to decode in terms of CPU, I say understanding what the instruction is intended to do, then you execute it. And then after it's executed, you go to the next one sequentially. And in terms of this illustration, the particular type of computers, the architecture that is following is a Von-Neumann architecture. And in fact, it's the architectures that we are going to focus on in this lecture. Okay, that's all for this mini lecture.